We're going to take an in-depth dive into how to add and subtract numbers on a number line, right? A lot of people still get mixed up with negatives. So if you still struggle with your negatives, you're in the right place. You're going to see, we're going to visualize every single one of these. We're going to make connections that you've never made before, and hopefully you'll learn something. So I've broken this up into six types of problems, depending upon what side of the number line you start on and which direction you travel, if you travel left or right. So right on the right side of the number line, we have the positives. On the left side, we have the negatives. And okay, let's see how this all works. So what I'm calling type 1 here is starting right, moving right, and ending right, meaning we're going to start on the right side of the number line. We're going to add, which means we're going to move to the right, and that'll imply that you're going to end on the right. So the first example of that is something like 2 plus 5, right? 2, we're going to start at 2, and then we're going to add 5, meaning we're going to move 5 units to the right. And if we do that, the question is, where are we going to land? So let's start on 2 and move 1, 2, 3, 4, 5 spaces to the right, and if we do so, we land on 7. So 2 plus 5 is 7. Good. Now I know that seems like, dude, why are you explaining this? It'll be useful to think of it this way when we get to the negative numbers. So 2 plus 5 is 7. All right, good. Let's go to the next one here. 1 plus 4, 1 plus 4. So that means we're going to start at 1 and we're going to move 4 units to the right. Let's see where that lands us. So we're going to start on 1 and we move 1, 2, 3, 4 units to the right and we land on 5. So 1 plus 4 is 5. That's what that means, right? Last example here of what I'm calling type 1 is 3 plus 6. We start at 3. We're going to move 6 units to the right and see where we end up. Starting at 3, we will add 1, 2, 3, 4, 5, and 6, and that lands us on 9s, right? So 3 plus 6 gives us 9. Good. All right. Now, we're going to do something very similar, but in the opposite direction, and this is what I'm calling the type 2 problems. So, right here, type 2, we're going to start on the left side of the number line, the left side of 0. We're going to move left. Which means we will be ending still on the left side of the number line. So, this would be something like negative 1 minus 5. So, we're going to start at negative 1, and because we're subtracting 5, we're going to move 5 units to the left, and we'll see where we end up. So, starting on negative 1, we will move 5 units left, and that lands us on negative 6. Therefore, negative 1 minus 5 is negative 6. Now, I hear people say, oh, do you basically just add 1 and 5? Yes, in a sense, but the answer is not 6. It's negative 6 because we're moving left, not right. And then what is our next example here? We have negative 6 minus 4. So we're going to start on negative 6 and we're going to move 4 units to the left and see where we land. Negative 6, 4 units to the left ends us on negative 10. So negative 6 minus 4 is negative 10. Sure, 6 plus 4 is 10, so negative 6 minus 4 is negative 10. Negative 3 minus 2, we start on negative 3. And we move 2 units to the left, and that lands us on negative 5. So negative 3 minus 2 is negative 5. Now, making connections. So here's something I want you guys to realize. Type 1 and type 2, and again, I've made this up. I've made up these types just for the sake of organization, but these type 1 and type 2s, they're opposites. They start on opposite sides and they go opposite directions, which leads to this very nice symmetry, but let's compare and contrast these. Let's do 3 plus 4, which I'm calling that type 1, and let's compare that to negative 3 minus 4, which is what I'm calling type 2, and let's see what happens. One's going to start on 3 and go right. The other's going to start on negative 3 and go left. Watch what happens. They're going opposite directions here. The one on the right lands on 7. The one on the left lands on negative 7, right? So 3 plus 4 is 7. And negative 3 minus 4 equals negative 7. Now, I do also want to show you something here now that I'm saying opposites. Negative 3 minus 4, that can be rewritten, I'm going to talk more about this in a little bit, but that could be rewritten as negative 3 plus 4, right? So you are adding, but it is the opposite, the negative. 3 plus 4 is 7, so that's why that ends up being negative 7 right there. All right, and then we have Right here we got 2 plus 5, and we got negative 2 minus 5. So these are going to start on opposite sides and work opposite ways. We got negative 2 and then to the left, and then we have positive 2 going to the right. And that's going to land us on 7 again. I didn't get very creative with that. So 2 plus 5 is 7, implying that negative 2 minus 5 is going to be negative 7, right? So that's how that works. That's how that works. Whatever your first number is, right? If your number is negative 2, you start on negative 2. And then if you have a minus, you go to the left, right? So that's what's happening there. Okay, and this brings us to this. Oh, beyond the number line, type 1 and type 2. So obviously, right, you're not just going to only ever add numbers that are less than 10, right? My number line is only from negative 10 to 10. How do you handle bigger numbers? So we're going to start here with this type 1 top row, and then we're going to use the fact that type 1 and type 2 are negative to figure out the second row. So here's how you add if you don't have a number line, right? We're not going to draw a number line from 12 and then count out, spaces, 25 spaces. So here's what you do. You vertically align the numbers. 12 plus 25. You vertically align the numbers. And then I'm going to start with adding the digits, the first digits, the 2 plus 5. 2 plus 5 is 7. And then I'm going to add the 1 and the 2 right here. 1 plus 2 is 3, right? So there you go. 12 plus 25 is 37. Let's keep going. Let's go 24 plus 8. You want to vertically align these numbers. 24 plus 8. And then we're going to add the first numbers. The numbers, this is called the ones place. We're going to add the numbers in the ones place. 4 plus 8 is 12. 12. That's 2 digits. You're going to write the first digit here, the 2, but then you're going to carry the 1, the tens digit, tens digit? Yeah. And now we do, 2 plus nothing, technically, so that's just 2. But then we want to add this 1, and 2 plus 1 is 3. So 24 plus 8, oh my goodness, I can't draw 3s. 32. I guess we'll live with that, is 32, just like that. This whole carrying thing is going to make a little more sense right here. Let's do this again. Let's go 47 plus 26. 47 plus 26. So I would add the digits that are in the ones place. 7 plus 6 is 13. And then I would carry the 1. And then I would just add up all these digits. The 4 plus 2 plus the 1 that I carried, which is 6 plus 1, 7. This is 73 right here. And then 88 plus 35. Write these vertically, 88 plus 35. Start with 8 plus 5. 8 plus 5 is 13. Carry the 1. And then 8 plus 3 is 11, plus 1 is 12. So this is 123. 1, 2, 3. Look at that. 1, 2, 3. Okay, why am I doing this? To show you how to handle this next row of problems. This is all connected. Type 1 and type 2 are opposites. Meaning, this right here, how would you handle this? How would you do this by hand without a number line? This is the opposite of type 1, meaning this is the same as negative, that's the opposite, of 15 plus 23. 15 plus 23. So if you want to do this by hand, you would just add 15 and 23. You would add 15 and 23 just like we did. 5 plus 3 is 8. 1 plus 2 is 3. But it's the opposite. So the answer here is negative 38. Right, this is the opposite of starting at 15 and going right 23 spaces. It's starting at negative 15 and going left 23 spaces. And if you do that on a number line, you will land at negative 38. So if you want to do this by hand right here, this is the same as negative 27 plus 6, right? This is the opposite of 27 plus 6. So 27 plus 6, we'll add that. Well, 7 plus 6 is 13. I feel like I've had a lot of 13s here. Carry the 1, and 2 plus 1 is just 3. So since 27 plus 6 is 33, negative 27 minus 6 is going to be negative 33. That's how that works, right? Opposites, they go opposite directions. Opposite directions. All right, negative 46 and 24. So if you want to do this by hand, this is the opposite of negative 46 plus 24. So if we add 46 and 24, 6 plus 4 is 10, so write down the 0, carry the 1, and then add up whatever remains. 1 plus 4 plus 2 is 7. Now, since 46 plus 24 is 70, negative 46 minus 24 is going to be negative 70. Negative 70. Last one. This is the same as negative parentheses 52 plus 49. So again, this is why I have students all the time. They say, hey, am I supposed to add these? Yes, in a sense. It is negative 2, it is negative 52 minus 49, but because it's the opposite of this addition situation, yes, there is this addition aspect to it. It's just the answer will be negative. Add these. 2 plus 9 is 11. Carry the 1. 5 plus 4 plus 1 is 10. So this is 101, implying that the answer will be negative 101. It is the opposite. All right. There we go. So that's how it works. If you start with a negative number and you subtract, you're going further left on the number line, which in a sense adds the numbers, but it is negative. It is negative. The answer will be negative on those. So good. That's how you do it without a number line, when the numbers are too big to sit there and count out. All right. So now we're on to what I'm calling a type 3 problem, which is we're going to start on the right side of the number line. We're going to start with a positive number. We're going to move left, and then we're still going to end on the right. So we're not going to end up in the negatives. So we're going to stay in the positives, but we will be subtracting. So right here, 5 minus 3, this means we're going to start on 5 on the number line. We're going to start on 5 minus 3. We're going to move left 3 units. And let's see what this looks like. If we start on 5 and we move left 3 units, 1, 2, 3, we're going to land on 2, right? So that is why 5 minus 3 is 2. 7 minus 6, we're going to start on 7, then we're going to move 6 units to the left, and we'll see where we, end up. Start on 7, move left, 1, 2, 3, 4, 5, 6, we end on 1. So that's why 7 minus 6 is 1. 10 minus 4, we're going to start on 10, minus, go to the left, 4 spaces. 1, 2, 3, 4, right? So 10 minus 4 is 6. 10 minus 4 is 6. All right. I'm showing you this because there's symmetry here. Now we're going to do the opposite of this, which is what I'm calling a type 4 problem. Type 4 is we're going to start on the left side. That is, we're going to start with a negative number. We are going to add, move right, but we're going to end on the left. We're going to end negative still. So in type 3, we started positive, went left, but ended positive. Here we're going to start negative, move right, and end negative. So our first number here is negative 8. Start on negative 8 plus 3. That means we're going to move 3 units to the right. And here we go. Start on negative 8 and add 3. 2, 3. And that lands us on negative 5. Negative 8 plus 3 is negative 5. Negative 5 plus 4, we're going to start on negative 5, and we're going to add 4, meaning we're going to move right 4 units. So negative 5 plus 1, 2, 3, 4 is going to land us on negative 1. Negative 5 plus 4 is negative 1. Negative 9 plus 7, we're going to start on negative 9 and move 7 units to the right. And we'll see where that lands us. Where do you think that's going to land us? Think of the answer before we get there. It will be negative 2. Negative 9 plus 7 is negative 2. All right. Good. So making connections here. There's obviously there's a particular order I'm going in here. Type 3 and type 4 are opposites, just like type 1 and type 2 are opposites. Type 3 and type 4 are opposites. And again, I'm just trying to make connections that will help you handle these problems without a number line. But let's look at this on a number line. So 7 minus 4 is going to be the opposite of negative 7 plus 4. That is, I'm going to start on one side on the right and move left, and then on the other side I'm going to start on the left and move right. So we're going to start on opposite ends and move toward each other. That's what's going to happen now. So start on a 7 and a negative 7 and move towards the middle. So 7's moving to the left, negative 7's moving to the right, and on the right we end up with 3. 7 minus 4 is 3, and the kind of complement, the mirror image of this is that negative 7 plus 4 is going to be negative 3, right? Opposite ends and move towards each other. Let's do that again here with an 8 and a 6. On one side, we'll start on a positive 8. On the other side, we'll start on a negative 8, and we'll move 6 units towards the middle. 2, 3, 4, 5, 6. So 8 minus 6 is 2. And then kind of on the flip side, negative 8 plus 6 is therefore negative 2. So these are mirror images of each other. They're opposites of each other. And then beyond the number line, right? So how would you do this then if you couldn't write out a number line? Well, let's start with how to subtract by hand, right? You've done this before, hopefully, right? 28 minus 13. I would start with 8 minus 3. 8 minus 3 is 5. And then 2 minus 1 is 1. So this equals 15. $35 minus 7. Set this up vertically. 35 minus 7. Okay, cool. So 5 minus 7. 5 minus 7. Can you subtract 7 from 5? Well, no, it's not enough. You're going to end up negative. Here, we don't want to do that. So when you're adding, if you had something extra, you carried it. When you're subtracting, if you don't have enough, you borrow, right? This is the reflection, the mirror image, the opposite of this. So I'm going to borrow 1 from that 3, turning the 3 into a 2 and making my 5 a 15. So what I can do now is subtract 15 minus 7, and 15 minus 7 is 8, and then just bring down the 2. So the answer here is 28. $44 minus 29. We cannot subtract 9 from 4 without going negative. So we're going to borrow, let me give myself enough space to make the point here. I'm going to borrow 1 from that 4, making the 4 go down to a 3 and turning my 4 into a 14. So now I can do 14 minus 9. And 14 minus 9, that's 5. And then now we subtract 2 from 3. 3 minus 2 is going to be 1. The answer here is 15. And so there's 15. And then we have 51 minus 16. I'm spreading out the numbers here to give myself some more room, because we can't do 1 minus 6 without going negative. So I need to borrow 1 from the 5. The 5 will go down to a 4, and my 1 will become an 11. So 11 minus 6 is 5, and 4 minus 1 is 3. So this is 35. So this is going to be useful. 2 things we're going to put together now. How to subtract by hand, which is what we just did, and the fact that type 3 and type 4 are opposites. Because if you want to do something like this, negative 39 plus 25 by hand, you can't put the 39 under the 25. The 39 has to be on top when you do this by hand, but we're going to reverse it. This is the same as the opposite of 39 minus 25. So what you're going to do is you're going to do 39 minus 25 by hand like we did. 9 minus 5 is 4. 3 minus 2 is 1. But it's the opposite. So this isn't 14. It's negative 14. Here we go. To do this by hand, you're going to use the opposite. This is the opposite of 24 minus 8. So I do 24 minus 8 by hand. I need to borrow 1 from the 2. 14 minus 8 is 6. Bring down the 1 for 16, meaning that the answer here is negative 16. The answer here is negative 16. Negative 62 plus 14. That's the opposite of negative, parentheses, 62 minus 14. 62 minus 14. 62 minus 14. Let's do that by hand. Give my digits some space to breathe here. So 2 minus 4, I need to borrow for that. So the 6 is going to go down to a 5, and I'm going to use a 12. 12 minus 4 is 8, and 5 minus 1 is 4. But this is the opposite, so it's negative 48. And then negative 57 plus 38. This is going to be the opposite of 57 minus 38. Borrow 1 from the 5. 17 minus 8 is 9. 4 minus 3 is 1, but it's the opposite, so it's negative 19. It's negative 19, just like that. Okay, good. All right, type 5. I'm calling this type 5. That is, we're going to start on the right side of the number line. We're going to start on the positive side. We're going to move left, but we're going to cross 0 and end up left. Essentially, we're going to start positive, subtract, but end negative. Let's see what that looks like. 5 minus 8. So I'm going to start on positive 5 on the number line, and then I'm going to subtract 8, meaning we're going to move left 8 units and see where we end up. So starting on 5, positive 5, we move left 1, 2, 3, 4, 5. We're crossing 6, 7, 8. So 5 minus 8 lands us at negative 3. We started right on the right side of the number line. We subtracted, and we ended on the left side. We ended negative. Let's go 3 minus 13 here. We're going to start at 3 and move 13 units to the left. So starting on 3, 1, 2, 3, we're crossing. See, we just cross into the negatives. We've got 10 more units to go once we make that cross. And where is that going to land us? That'll land us all the way down here at negative 10. And then 9 minus 10. Start at positive 9 minus left 10 units. And where do we end up? Think about what you think the answer is going to be before we get there. What is 9 minus 10? What do you think? It's going to be negative 1. Type 6 is going to be, here, I want to make connections before we get to type 6. So type 5 is the same as type 4, which is the opposite of type 3. And again, you don't have to memorize these types. This is something that I made up for this video just to organize everything. But hopefully you're just going to start to make sense of the math. The types are just training wheels. So what I'm saying here is type 5 is the same as type 4, which is the opposite. So how would I do this by hand? Just FYI, this is the same as the previous type, which was negative 45 plus 24, which was the opposite of type 3, which is 45 minus 24. These are all the same thing. I'm just getting you into a position to actually do this by hand. The part that you have to do by hand is 45 minus 24. So we go 45 minus 24. 5 minus 4 is 1. 4 minus 2 is 2. But it's the opposite, so the answer here is negative 21. Now, if you understand that this is what you have to do when you see this, you don't have to write all these steps down. This is just to show you how these things are connected, right? This 24 minus 45 is just the opposite of, 45 minus 24. So flip it around, but remember that your answer is the opposite, negative. It would be the same thing here. This 17 minus 52, that is the same thing as negative 52 plus 17, which is the opposite of 52 minus 17. So the part here that you have to do by hand is 52 minus 17. 52, give yourself some space because we're going to borrow here. Borrow 1 from the 5. 12 minus 7 is 5. 4 minus 1 is 3. And so this will be negative 35. That's how these things are related. Now type 6. Type 6. We're going to start on the left side. We're going to move right, but we're going to end right. So we're starting negative, but we're going to add enough that we cross the 0 and end up in the positives. Starting with negative 4 plus 9. So start on negative 4 on the number line. Add 9. Move 9 units to the right. Where do we end up? Negative 4 plus 9. And so see here, we're going to cross. We're crossing into the positives. Where are we going to end up? We're going to end up at 5. Negative 4 plus 9 is 5. All right, negative 7 plus 1. Think, what do you think the answer to negative 7 plus 1 is going to be? Start at negative 1, move 7 units to the right. We're already in the positives. Where does this land? It lands us at 6. Negative 1 plus 7 is 6. Negative 8 plus 16. This is the longest animation I have on this video. We're going to start at negative 6. No, negative 8. We're going to start at negative 8, and we're going to travel 16 units to the right. Where will that land us? Well, the first 8 units of that is going to get us right in the middle. So once we hit that 0, boom, 8. Now 9, 10. We're still traveling. Where is this going to end up? Right there. This is a very symmetrical problem, right? It's evenly split on both sides. Negative 8 plus 16 is positive 8. Okay. I do want to make one more connection here. Making connections. Type 6 is the same as type 3. Again, don't try to memorize these types. Your teacher's not going to teach it this way. They're not going to even say these words in your class. This is something I made up. But just watch how this works. Negative 21 plus 37. When I say this is the same as type 3, I'm saying this is the same as 37 minus 21. You don't have to do any opposites here because 37 minus 21, that's the bigger number first. So put the bigger number on top. 37 minus 21. 7 minus 1 is 6. 3 minus 2 is 1. This is 16. No opposites. Just flipping it around. It's the same thing. So, what I'm trying to teach you right here is that negative 18 plus 56 is the same thing as 56 minus 18. So we can do this by hand. 56 minus 18. Borrow 1. 16 minus 8 is 8, and 4 minus 1 is 3. So this is 38. It's not negative 38, just 38. Just 38. Okay. Good. So that's all 6 possibilities of what could happen on a number line. If you start on the right and go right, you're going to end right. If you start on the left and go left, you're going to end left. If you start right and go left, you might end right, but you might end left depending how far you go, and vice versa. So that's really the most detailed I could be about what all could happen on a number line. So what I want to do next is go to what's called the commutative property. Maybe you've heard this word before. And we've actually been using the commutative property when I said, oh, this type is the same as this type. We've flipped things around, and you can do that. You can do that. Now, you may have heard of it called more specifically the commutative property of addition. I mean, there's a commutative property of multiplication, but we're not doing that right now. The commutative property of addition, and yes, that's proper. There is no commutative property of subtraction. Subtraction doesn't commute, but that doesn't mean that the commutative property can't be applied to problems that have subtraction in them. You just have to do it right, and I'm going to show you how to do it right. We're going to start with, a type 1 problem where you start on the right and you move right. So 2 plus 6, but the commutative property here says that you can switch the places of these numbers. So 2 plus 6 is the same thing as 6 plus 2. Those are the same things. If you start at 2 and move right 6 units, you're going to end up in the same place as you will if you start at 6 and move 2 units to the right. So check this out. Here's what I'm saying. You're going to start at 2 and you're going to move 6 units to the right. 2, 3, 4, 5. 6, right? That's 8. 2 plus 6 is 8. Now, it'll be the same thing if I start at 6 and I move 2 units to the right. That will also land you at 8. 2 plus 6 is 8, and 6 plus 2 is 8. Same thing, right? That right there is the commutative property of addition in its purest form. But you can still do this if there's negatives involved. You just have to keep whatever number is negative, right? Well, here they're both negative. So negative 3 minus 7 is going to be the same thing as negative 7 minus 3. You can flip those around. They're both negative. Flip them. Let's see what happens here. If we start at negative 3 and we move 7 units left, where's that going to land us? Where will we end? It's going to be negative 10. And that's the same thing as if we start at negative 7 and move 3 units to the left. We will also land at negative 10. Both of these are negative 10. It works both ways. So yes, it's properly called the commutative property of addition, but it works here too. You're going to start to see the big picture here. I'm trying to generalize this for you. Next, we have what I've been calling a type 3 problem. We're going to start with a positive number, subtract, and our answer is still going to be positive. Now, be careful here. This is not the same as 5 minus 9. This is not the same as 5 minus 9. We're going to flip these, but not like that. You have to keep whatever's positive has to stay positive, and whatever's negative has to stay negative. You can't change the sign on a number. You can swap numbers, you can switch, but you can't change the sign. Notice how this 9 is positive, but this 5 is negative. So as I switch these around, my 5 has to stay negative and my 9 has to stay positive. This is how you accurately apply the commutative property to this problem. Here we go, let's watch it. If we start at 9 and we subtract 5, that is we go 5 units left, we are going to land on 4. And the same thing will happen if we start at negative 5 and we add 9. So this is going to be a longer travel, but we switch into the positives and we land on 4 as well. These are the same thing. 9 minus 5 is the same thing as negative 5 plus 9. Same thing. Okay, so how would you apply the commutative property to something like negative 8 plus 7? You can flip the 8 and the 7, but the 8 is negative. It needs to stay negative, and the 7 is positive. It needs to stay positive. So this is the same thing as positive 7 minus 8. Starting at negative 8. If we add 7, where are we going to end up? What is negative 8 plus 7? It's going to give us negative 1. Now this is the same thing as if we start at 7 and subtract 8. We're going to cross into the negatives. Right there, we'll get to negative 1. Here we have 4 minus 10. We're going to start with positive 4. That's a positive number. We're going to subtract 10. That's going to end up in the negatives. But this is the same thing as, it's not the same thing as 10 minus 4. It's the same thing as negative 10 plus 4. The 10 has to say negative. The 4 has to say positive. And then that way, these things will commute. Starting at 4, and moving 10 units to the left, that crosses us into the negatives. Where will we end up? That lands us at negative 6. Same thing, we could start at negative 10 and add 4, moving 4 units to the right, will also land at negative 6. Those are the same thing, And then type 6, starting negative, adding, and ending positive. This will be the same as 9 minus 3. And let's see both of those. Starting at negative 3, we're going to add 9. We'll move 9 units to the right. Here we are crossing into the positive numbers. And we end up at 6. Starting at 9 and moving 3 units to the left, 9 minus 3 will also end us at 6. Those are the same thing. So that is how the commutative property works, right? It is the commutative property of addition. It's not the commutative property of subtraction. But again, it doesn't mean that you can't use it when there's negatives at play. Just keep your negatives negatives and your positives positives, and you can flip them around if you want to. You don't have to. It's a matter of preference. It's just one more tool, one more skill that you have. Okay, good. The last thing I want to address in this video is adding and subtracting negative numbers. I see this confuse people as well. So let's cover this. All right, 10 plus negative 8. So based off of what I've been teaching you, what would you do? You would start at 10 on the number line. And then you see plus, which I've been telling you means if you see plus, you move to the right. But then you see this negative sign. And that's kind of like a psych, do the other thing, right? It's telling you to reverse what you were doing. We were moving right, but then we hit this negative and says, no, just kidding, go the other way. Go the other way. So this is really just 10 minus 8. This is really just 10 minus 8. And we'll answer that in a minute. You probably already know what that is. But before we play the animation, I want to show you one more thing. There is an implied 1 right here. You could put a 1 there. That wouldn't change the value of the problem. And this right here, if I'm just looking at that plus 1 parentheses minus 8, whenever you have a number against a parenthesis, the implied operation is multiplication. So we could just simplify this mess. This is a mess. Everything in the blue box, it's too much. What is positive 1 times negative 8? What is positive 1 times negative 8? That's just negative 8. So everything in my blue box simplifies to minus 8. So that's another explanation as to why 10 plus negative 8 is really just 10 minus 8. Those are the same thing. Now let's observe what this would actually be. So you start on 10 and you move left, not right, but left, because that 8 is negative. Moving left 8 spaces will land us at 2. Right? So 10 plus negative 8 is really just 10 minus 8, which is 2. Seven plus negative 11 is the same thing as 7 minus 11. Same thing, less writing, less clutter. Start at 7 and move left 11 units. Nine, 10, 11. There we go. It's negative 4, negative 4. So 7 plus negative 11, which is really just 7 minus 11, is negative 4. How about negative 1 plus negative 5? So again, it's like, okay, start at negative 1, move to the right. Just kidding, go to the left. 5 units. That's what that means. It's a change. It's like it's changing its mind. This is the same as negative 1 minus 5. So negative 1 minus 5. That means we're going to start at negative 1, but we're going to go left 5 units. Start at negative 1, go left 5. 1, 2, 3, 5. Right there. What is that? That's negative 6. So negative 1 plus negative 5 is negative 1 minus 5, which is negative 6. All right, here we go. Double negatives. 2 minus negative 6. So I'm going to teach this with that implied 1 like I did earlier. You could stick a 1 here. There technically is a 1 there. And let's simplify this. Not the 2. I'm going to ignore the 2 for now. Let's simplify everything in the blue box. That is negative 1 times negative 6. What is negative 1 times negative 6? Well, a negative times a negative is a positive. So this is the same thing as 2 plus 6. It turns into a positive. This double negative, now let me erase the 1 here. This double negative turns into a positive because a negative times a negative is a positive. I know we're not talking about multiplication. This is about addition and subtraction, but it kind of makes a guest appearance here, right? 2 plus 6. So 2 minus negative 6 is really 2 plus 6, meaning we start at 2 and move 6 units to the left, right? You already know what that is. Lands us on 8. So 2 minus negative 6 is positive 8. So in the same way, -3 minus -12. Now this only changes the double negatives. It doesn't change the negative out front. This negative right here, this negative out front has nothing to do with the negatives in the middle. It's the negatives in the middle that combine. But that 3 will stay negative. So this is the same as -3 plus 12. So we start at -3 plus 12. We move 12 units to the right because we are adding. This crosses us from negatives to positives, and we're going to end up, where does this land? 9. So -3 minus -12, the most negatives possible in this type of problem, is going to end up being +9. And then this brings us to our last problem, -9 minus -7. That's the same thing as -9 plus 7. Again, the double negatives turn to a positive, yes, but the -9 remains a -9. -9 plus 7, we start on a -9 on the number line, and we're adding 7. So we move 7 units to the right. We'll remain negative. What's the answer? Answer there is -2. Good. Okay. So that's how you add and subtract numbers on a number line. I get people get confused. It can be confusing, but I want you to picture that number line in your head, right? Whatever the first number is, that's where you start. And if it's plus, you move to the right. If it's minus, you move to the left and see where you end up. Be careful trying to memorize a bunch of different rules. You're going to confuse yourself. Understand how this works. Start on the first number, and if it's plus, you move to the right. If it's minus, you move to the left. Great. Hope this helped. Hope you feel a little more comfortable with adding and subtracting numbers. Thank you for sticking around. We'll see you in the next one.